Welcome to qnawire.
For this problem, we are using the guidelines for graphing polynomial functions to graph g of x. And the first step is to identify the end behavior of the function. To do this, we need the degree, which is simply the exponent of the x term that's raised to the highest power. Here that term is 3x to the fourth, meaning we have a degree of 4. That's an even number. And when you have a degree that's an even number, it tells you that the graph end behaviors are the same on the left and the right. But that still doesn't tell us if it's up or down. That's why we need the leading coefficient. I'm going to refer to that as a. If a is greater than 0, positive, then both end behaviors will be up. If a is negative or less than 0, they'll both be down. Going back to our equation, our leading coefficient is positive 3. So our end behavior is left up, right also up. And then the next piece of information that the guideline asks us to find is the y-intercept, where the graph crosses the y-axis. Another way to think about this is what happens to y when x equals 0? To solve, set the equation equal to y and substitute 0 for each x term in the equation. So I'm writing this out, and you may be able to see, without writing it out, what's going to happen. Since there's an x term in each a piece of the equation, the y-intercept is the origin, 0, 0. All right, so now that we have that, the next step is to identify the zeros of the function. I'm going to rewrite the equation, and I'm going to factor out x squared. This gives us a different way of looking at it to continue solving for our zeros. So first we see this x squared telling us that x equals 0 is a 0 of the function. Not only that, this squared tells us that it has a multiplicity of 2. All right, so now that I know that, the next place I'm going to go is to check whether or not positive 1 is a 0 of the function. To do this, you add together the coefficients of the equation, and if their sum equals 0, then positive 1 is a 0 of the function. Okay, so we have 3 plus 2 minus 8. This equals negative 3, so it's not a 0. However, it does tell us that 1, negative 3 is a point on the graph. Okay, so then I'm going to check for negative 1. Same process, except if the x term is raised to an odd power, we're going to switch the sign. So we have 3 minus 2 minus 8. All right, so that equals negative 7. So again, that's not a 0 of the function. However, negative 1, negative 7 is a point on our graph. Okay, so this leaves us with another option, because we're looking at just this 3x squared plus 2x minus 8. I'm going to use the quadratic formula to solve this. This should feel familiar. X equals the opposite of b, plus or minus the square root of b squared minus 4ac all over 2a. Filling in the values of my equation, negative 2 plus or minus 4 minus 4 multiplied by 3 and negative 8. And all of this divided by 6. And then I can simplify this down. Negative 2 plus or minus 10 divided by 6. So then my two values here are 4/3 or negative 2. In this case, both of these are zeros of the function. This enables me to rewrite my equation once again in its factored form, which is x squared multiplied by x minus 4/3 multiplied by x plus 2. The reason I wrote this way is because standard form for the factored equation is x minus c raised to the power of m. Subtraction is the standard operation, c is the zero itself, and m is its multiplicity. Now I want to identify whether the multiplicity of each of my zeros is even or odd. So looking at 0 raised to the power of 2, so that's an even number. 4/3 raised to the power of 1, and -2 is also raised to the power of 1, so these are both going to be odd. And the reason I'm doing this is because with multiplicity, if it's an even number, then the graph will bounce off of the x-axis at that point. If it's odd, it's going to cross the x-axis. Okay, so now we know how the graph behaves at each of our points. So I'm going to graph my y-intercept and my zeros. We have our origin for our 1, 0 and our y-intercept, and then we have 4/3, we have -2. And we know that our end behaviors are left up and right also up. We have a lot of information, but we still don't have quite enough. We got to remember these 2 points that we have, so I'm going to go ahead and graph those. -1, -7, and 1, -3. And now it looks like we're in good shape. Starting at -2, I can start sketching the curve, working down to that -7, up to 0, where I'm going to bounce off of the x-axis, and then crossing through 4/3, then continuing up for that end behavior. Going back to -2, I also want to continue that up for that end behavior. And then just smoothing this out, make it look a little more purposeful, because we're not hesitating. And then don't forget your arrows on the end, because the graph does continue infinitely. And we're all done.